Hello, everyone. Just getting things up and going. All right, we're good. All right, let's see what our DM is. So yeah, there. Oh my gosh. Okay, I don't know. This question from this is 1 day ago. I think it got deleted, but or no, because the timing's just weird. But it was fake proof. It said to spot the error, and I found the error, and this person keeps insisting that it's not an error. I don't really know what they're saying, but it's not really important. The person got their answer and they deleted the post. Oh, I guess even though it's deleted, you can still see it through certain like links, I guess. So let's just look for new questions. No one has an answer. Let's get homework help. Consider this equation. Oh. So they just need to know like what this question is even asking. I haven't seen one that's like this before. And so basically you would want an arrow that goes both ways if you could reverse the steps and still be doing valid math. So like if you square both sides, you can't necessarily go back and square root each side because you don't know whether to take the plus case or the minus case. I think it's kind of the point that's being made. I mean, basically, if A, then B, where A is, oh shoot, I want to actually have the arrows here. I use the word basically a lot, and I feel like I shouldn't use it so much. The arrow going the different directions show the flow. I feel like this is getting a little sorry down the wrong track with saying flow is a little bit like fluffy wording, I guess, not exact. A simple example is x plus 3 equals 5 implies means A implies B. Maybe implies. Also say if A, then B implies x equals 2. Well, this technically goes both ways. So or if x plus 3 equals 5, then x equals 2. However, you could also reverse this and say if x equals 2, then x plus 3 equals 5. So you can also use the double arrow that shows the steps work in both directions. You can start from either step and get to the other. That's fine. Just we'll leave it at that. It can get tricky to tell, or the above example works. The above example shows a manipulation, or shows Yo, Bookbinder, how's it going? Glad to have you here. I'm just working on a little right for someone on what kind of the implication arrows. I don't know if I have a better word to call them, but like if-then arrows or if and only if. And it's like, I know what they mean, but it's kind of hard to put it into words, so I'm like kind of struggling through that right now. So-called if and only if. Hey, SPQ. Doing derivatives. Ooh, fun. Hey. Yeah, RY? Yeri? Probably saying that wrong, but welcome in. I should put a little... That's fine. Underscore hate. Yeri? Okay. Yeah, I'll show it because we just had a few people pop in. Has someone else replied in the meantime? Okay. I would need to refresh, but they're asking for like what this question even means. Which I haven't seen a question ask this exact thing before, but I think their confusion is more or less like, what the heck do these arrows mean? So I'm trying to put it into words because I understand it, but I like have a hard time explaining it. So I'm trying to find words to explain this, I guess. And Bookbinder, I'm doing well. A little bit tired, but I'm good. How about you? Thanks for asking. Not all steps in solving an equation work in both directions, though. I'm going to use the first two lines as an example. First two steps of the given problem. Your exam's in less than 2 weeks. Oh, geez, good luck. Well, actually, in the first step, not even the first two steps, both sides are squared. that's fine. So we can at least do this. However, if we square root, however, we also need to figure out if we can do the reverse, square rooting each side. If you have x squared plus 9 equals 9x squared minus 42x plus 49, and square root each side, pretending we don't know. Well, let's root each side. We get plus or minus. Oh, that's not minus. Plus or minus square root. Let's look at the square root symbol. Square root symbol, where are you? There you are. X squared plus 9 equals 3x minus 7. The plus or minus, we can't figure out which version of or whether we should take, we can't figure out whether to take the plus or the minus case, or we don't have enough information to know whether to take the plus or minus case, so the implication arrow can only go one way here. Hey, Hardlocked. Yeah. Some bookbinder. Are you from science background? No, I majored in applied math and I minored in computer science. So I guess just a math focus, basically. Okay. I think this is my answer here. Woohoo! The green hearts are here. Shoot, I forgot about the corgi emotes, but the green heart was at least super easy for me to do. You like it? Oh, I'm glad. Oh, let's see what someone else wrote. I'm kind of curious to see how someone else would explain this. Oh, I don't see their comment though. Okay. Awesome. Dude, I was like having a mini crisis with like figuring out what shade of green, because there were two that looked the same but were slightly different, but actually it is really close to the shade of green as your name. Might even be the same, I don't know. Derivative of multiple derivatives. So the dots are with respect to time. So I think we do need chain rule here, I think. Yeah, what's up, Bookbinder? Is Q only a function of time, I guess? What would happen if Q is a multivariable? Means not A or B. Those identities I have a hard time remembering. I really was weirded out when I took a what's it called? It was called operating systems, but it really felt more like computer architecture, I guess, or I don't know. I might be mixing my terms a bit, but you have to like the classes basically start from a NAND gate, and you have to build up, you know, to a basic computer, and like making NANDs have the same result as like binary addition was super weird. And I feel like it's the same sort of idea as like if A then B, meaning also not A or B because it's the same output. Do study with me live lesson. Where you mean like I'm studying something and then like someone watching is also studying their own thing? Or like, do you mean like you bookbinder want to study like with me? Oh shoot, you said yes, but I asked you two different things. I'm really bad about that. I'm sorry. I see you're saying yes to the first thing where like I'm studying something. I kind of do that where I'll do like real analysis questions if I don't have math questions to work on. I've been thinking about doing like some differential equations stuff or something on stream, or even complex variables. I put my book on it away. Like it's I oh, okay, I'm glad. That's a good point for gamma ray burst. We don't. Okay, well, I'm not gonna. This one has an answer now, but. So yeah, but when I've been thinking about doing like some kind of like study stream, but it's probably going to happen more over like summer when people don't have as many math questions. And even then, like I would enjoy it like every now and again, but I don't think I'd be able to do that as like the normal thing. Is this the floor function? You have to integrate the floor function? Why? Oh, and the thing has like 2 pixels total. I think you have to do this manually. In common logic, that's totally true. You could even derive the statement out of axioms with deduction. Oh yeah, I'm sure there's a way that you can just you know, use propositional logic to get from one statement to the other. I guess I learned a little bit about it in discrete math. Study with me for 12 hours? I have a hard time doing a 12-hour stream, especially if it's about math, because that sounds exhausting. But over on Twitch, Penn Center, the Beast is actually right now doing a 100 integral stream. And he said he's going to go all day. I don't know what all day means, but he's been going for at least like 4 hours now or something. Use truth table, you can drive it with deduction and in other direction. Oh, okay. So this is basically integral. E is 2.71, right? I should know that. Basically from 2 to pi? 2.71? Oh my god, it's showing me everything. Wait, Wolfram Alpha isn't showing me the actual value of E? Okay. That's interesting. Yeah, okay, 2.718. People specialize in logic or set theory. I fear them. So yeah, the integral from 2 to 3 of floor 3x. I don't see a way to do this other than graphing floor 3x and finding the areas of the rectangles. Just for, actually, oh my god, so I'm not gonna be able to use my whiteboard today because the thing that holds up my phone that I use to get the big cam is broken, so I need to order a tripod or something. But we have the next best thing, which is paint. So y equals 3x. We only really care about it between 2 and 3. So 1, 2, 3. I drew this. Okay. We have a whole bunch of extra slack here that we're not gonna need, but it's cool. Wait, is my cursor? No, it shows up. Okay. Take care of stuff. Have a good stream. Awesome. Sounds good. Underscore. Thanks for hanging out. Space it out a bit. There we go. A few years ago, our new strong warrior, Terrence Tao, our army got bigger. So 3x, that means when x equals 3, y will equal 9. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Oh, all right, Bookbinder. See you around. Thanks for being here. This scale is horrible, but oh my god. Hey, Obi. And then now if we want floor 3x, I think it's gonna divide it into thirds. So between 2, what is 2 plus 1/3? 7 thirds? Yeah, that makes sense. Floor. So once we're exactly at 2, that'll be included. So x equals 2, y equals 6. Closed dot. We go to the right until we hit the third mark, and then we open dot. I think this is going to be the pattern. I didn't actually... I should plug in some more numbers to like calculate it, but I think this is our pattern here. And if we want to integrate this, we just have... Oh god. We just need to find the area of these 3 rectangles here. Just like it's actually kind of like a Riemann sum. Actually, it's exactly like a Riemann sum. That's kind of funny. So I don't think, I doubt the floor function really has an explicit integral. Actually, I bet you that Desmos can do the floor function too, if it ever decides to load. See a Bookbinder? Think it can? Okay. Yeah, there we go. That's probably I can share this graph. So yeah, okay, just between 2 and 3, we have the 3 steps here. Okay, perfect. That button, copy. To my knowledge. Okay, so, well, we should explain what the function is in case they don't know that. Do we have, is there a symbol? Is there like a character for the floor? Okay, I was trying to figure that out. Oh, OB. Yeah, a third makes sense. That looks like a floor symbol to me, doesn't it? So, is the floor function, meaning you round down any decimals. Floor E equals, or since E equals 2.71 ... floor E equals 2, and floor, we need pi. It's 3. As far as I know, you can't find an antiderivative of floor x so this has to be the easiest way to do this is graph the function and calculate the area under it geometrically. I mean, it's definitely difficult. I haven't seen the floor function before. The actual math involved isn't going to be that bad once you figure it out, though. It's going to be finding the area of 3 rectangles is all it boils down to. Getting to those 3 rectangles is definitely, it's not easy, though. I wouldn't... I don't want to pretend like this is super... I mean, to me, I can get it quickly because I've seen it before, but... not everyone has seen it before, so... Spectry! Wow, yeah. People were sleeping on getting that first. I think people who can sleep on single example. Yeah, Yeri, I try really hard to remind myself that some problems for me are just really easy because I've done them a million times, but they're not easy as someone who's seeing them for the first time. So that's something I try to always be conscious of, and I try not to call things easy if I can help it. Because what's easy to one person isn't easy to another. Y equals x times floor x, Jeff? I doubt it. Would it? I guess if we're doing the floor 3x, we can do... Well, with chain rule, that'd be... I don't... Okay, no, let's get rid of the 3 to make things... Whoa! That's definitely not it. Wait, floor x should... Wait, is it? This is not changing. What is this? No, wait. I don't think you can, because it doesn't... The change doesn't happen in a smooth curve. Yeah, it's like the change is 0, and then instantly it rises up, and it's not changing. So I think the derivative, it's 0 except at those breakpoints, and it's undefined at those breakpoints, I would think. That's my guess, just from intuition, I guess. It's similar to y equals 3x, but it looks like a staircase because the decimals are rounded down. See here. And this is where I want my Desmos link, I think. Oh, no, I do not want to share that. To not confuse them. Between 2 and 3, we end up with 3 steps to calculate the area under. So we just need to get the area of those 3 rectangles. Okay. It's kind of a fun question. I'm sure that Desmos link works. If I find a continuous function, it's still not differentiable. Points 1/3. Continuous function, not sure how it works. Could you get a Fourier series and derive that? That's I don't understand Fourier series well enough, but that's my only, like, if I'm really grasping for some way to get a derivative, that's the only thing I could think of. Well, even then, wouldn't it be periodic? I thought Fourier series worked for anything, but it might only be periodic functions. I'm not really sure. Oh God. Well. Oh no, that actually is not too bad. You multiply by root x plus 7 minus root x minus 5, and I think you get rid of all the square roots. Yeah. That would be nice, but no, it doesn't work like that. Okay, let me make sure the thing that I just said works. If you have root x plus 7 root x minus 5. Oh, wait. The other side is going to be the issue. You can't multiply both sides by that because, well, you can, but it's not helpful. I guess you do have. Do you just have to square it? That's going to be annoying. Yeah, I guess you do have to square it, Jeff. Square, well, that's, I guess you can get everything else on the right-hand side and then square it, and then you are making progress, yeah. Yeah, just always ending up with more square roots involved. Hey, Bio. Nothing much. So we get a 2x, that's minus 2x. We get a 7, a minus 5 is positive 2, subtract the 2 over, and you get plus 34. Good. Divide each side by 2. Okay, yeah, and when you square this, you get something that's manageable. That's going to square to x squared minus 34x. 17 squared? Who has that memorized? Let's go to Wolfram quick. 289? Yeah, you're right. Now this is something that's a lot more familiar for how to solve for most students. Okay, yeah. Oh, yeah, actually, it becomes linear as well. Even better. 289 plus 35. That's 294 plus 30. 334. Complex numbers into trig form? Yeah, I can do that in a minute. You have more roots, so you can just check all of them. Like, maybe from like this step here? Oh, is it 324? Oh yeah, you're right. Minority suspect, thank you. Like the zeros of that? I don't know if that would get you where you want to go, but maybe. It could save you some algebra if that does work. 36 divided by 324, is that a nice even number? 324, 36. 9. 9. All right. And does 9 work here? 9 plus 7 is 16, which becomes 4. 9 minus 5 is 4, which becomes 2. So 4 plus 2 is 6. Hell yeah. All right. Wait, so would we have gotten, we wouldn't have gotten x equals 9 from anywhere else though, would we? X equals 9 isn't a root of any of these things if you consider them on their own. I don't think, unless I'm misunderstanding what could be another root you lose by squaring. Oh gosh. Well, it's unidirectional in the, well, I guess, There's potential for negative x's to, no, there isn't. But I guess that's true. I don't know. I mean, let's check it with Wolfram. I don't know how you would get the other root is, whatever it is, though. You don't think there's just annoying? He's just like annoying me. That's fair. I respect it. Oh, SPQ, that's a nice way of thinking about it. Assuming it is strictly increasing. I guess it would be strictly increasing, like root x is strictly increasing. This is a combination of root x's. So yeah, okay. I like that. Okay, so this person, they actually did do the first step right. They just need to, we need to show them that it's actually not that bad. X squared minus 5x plus 7x minus 35. Does that match what I had? X squared plus 2x minus 35. Yeah, okay, that matches. You actually do have the work right so far. It matches my work anyway. It does look like a monstrosity, but it's not so bad if you know the trick. From your last step, you want to isolate the square root, then square both sides again. It's a bit of a pain to do all the algebra, but it will simplify down to one number in the end. So subtract x plus 7 and x minus 5 and divide by 2. Rules of transformations. Like doing a change of variables here? I don't know what the change of variables would be, but there probably is a change of variables way to do it. Binomial theorem I'm not as strong on. But if you just have a normal complex number, let's take, what would be a case that isn't too bad to calculate? If we just have the complex number 1 plus I guess just to keep the cases, or to keep it relatively simple, I would personally put it into like polar form with the exponential, and then just do it into sine and cosine with Euler's ending, but I think you can go directly to sine and cosine. So let me try it that way, I guess. So to get it into trig form, we need to figure out the radius first. A formula, if this is a plus ib, a formula for the radius is root a squared plus b squared, which in this case we have 1 squared is a, and then b is another one, even though we haven't written one. So 1 plus 1 is 2, so our radius is root 2. And then the other component that we need is theta. And that's the angle that it's going to make with the positive x-axis. It's equal, I'll write arctan. Sometimes represented as inverse tangent, but that notation is sometimes confusing, so I tend to write arctan. But it's arctan b over a. Which is arctan 1 over 1, and I'm good with my unit circle, so I know off the top of my head that that's pi over 4. There is a potential issue here where arctan, its domain is restricted, meaning you do have to do a little check to make sure that pi over 4 does actually correlate with 1 plus I. Because arctan just gives you the reference angle, but it's not always the angle that you actually want. In this case, I gave a relatively simple example where 1 plus I is right here in the first quadrant. So here in the first quadrant, I think we're pretty much always fine with arctan. This angle right here is pi over 4, and so that's what we wanted. If we were given something like minus 1 minus I, the same thing but the opposite. 1 minus I might still work, Jeff. All right, no, you're right. 1 minus I is a good example too. But I'll just use the one that I said with minus 1 minus I. You will still get arctan of 1 equals pi over 4. But in this case, you have to know that the actual angle you want is all the way over here. So you have to take your pi over 4 and add pi to it to get that 180-degree rotation in there. That's a potential trap that you can fall into with arctan. And so now we know our r and our theta, so we can just plug right into the form for trigonometric exponential number, or complex number. It's radius times parentheses cosine of your angle plus I sine of your angle. Sometimes abbreviated to CIS, just because it's a lot of writing to do cosine plus I sine a bunch of times. And yeah, bio, exactly what Jeff said, where it's the same exact procedure, you just don't always get numbers that look as nice. Like if you get a non-unit circle value, I think you're just stuck with an ugly arctan. As far as I know. Hey, Ben. How to know if you have to switch to trig? And I guess it depends on what you're doing. I'm not sure. My complex variable knowledge isn't strong enough to give examples for when this trig form is more convenient. Yeah, Dom D, not Dom B. We can look at root 3 minus I over 2. I think that actually will clean up nicely to be unit circle, though. At a glance. We can certainly look at this example that you say. Everything to the power of 2007? Oh, for this you need Dimlov for powers of complex numbers, which actually, I remember that off the top of my head, I think. A plus IB to the n is equal to r to the n times cosine n theta plus I sine n theta. So you do the exact same thing that I showed you up top there, like up top here, but you just plug in your n. In this case, you have 2007. Oh yeah, or as Obi said, you get into exponential form in the formula. You don't have to memorize it if you do that. Oh, everything's over 2. Okay, it's still the same. It's still the same, regardless of what your numbers actually are. It's the same. The procedure is the same every time. And if everything's over 2, you can also split it up like I have here too. I'm not surfing right now, Ben. I'm doing math. Oh yeah, I mean, if you wanted to, you could multiply this out 2007 times, or I guess 2008 times, or no, 2007 times. But this form is a lot easier, so I recommend you use that. Just solving that for x? Yeah, Jeff, like the formula I said here is the like result of that, I guess. And honestly, I probably, if I was in an actual complex variables class, I would probably have memorized it that way. But I've like hurriedly Googled what the heck the power of a complex number is enough times that I happen to memorize that formula. Yeah, I think complex numbers are super interesting. I want to learn more about them. So you have sine x plus sine 2x. Yeah, that's the binomial theorem way. It will take a lot of writing. I think that's cosine squared x, not 2 cosine x, right? And there's one thing with numbers that consists not of 2 but of 4 parts, like a complex number, like a 4-dimensional complex number, I guess. I mean, at that point, I feel like you're just talking about vectors. Quaternion? Oh, okay. I know basically nothing about that though. From physics for motion. That makes sense. So you have like time and then 3 dimensions of space. To tackle this one, I times j equals k because it's a cross product. Oh yeah, okay. But j cross I equals minus k. Oh yeah, because the way the cross product is like right-handed, right? Well, fractional powers of complex numbers are not simple. You have to be careful with them. I don't want to say that's where you're going with that bio, but I'd be careful about taking a fractional power of a complex number. It doesn't work the exact same with as with real numbers. For this one, what identities? Like, I could do half angle, but I don't know if I want to do half angle. Or double angle. It's all the same to me. You probably have to, though. We kind of need the phases to be in line. I don't see, like, a one-step way to, well, I don't see, like, a... you just have to start trying stuff, bio. I'm about to just start using... Like, I'll just start applying random identities here. So sine 2x is equal to 2 sine x cosine x. I don't know. I don't think this is going to really help us, though. I don't see where this is going to go. But let's get everything on the same power and the same angle and see where that gets us. Cosine squared x is, looking at my sheet, 1 plus cosine 2 theta over 2. But then that cosine 2x is a bit of an issue. This is where we kind of start going in circles there. Be cheating to use e to the I theta? Oh, for like a fractional power, Jeff? You do use e to the I theta, but not as simply as I think you're suggesting. Like it does involve doing the exponential form, but you still can't just do the normal dividing the power by 4. Oh, you mean this? Taking things to complex? No, that's probably not the intent of the question. It might make it easier though. Well, you still have different powers of e. I don't know. So the I use an identity here with the cosine squared. The cosine squared is just equal to this. Okay. But this is, like I'm saying, this might not really help us because now we have a cosine 2x that I don't quite know how to deal with. So we could leave it as cosine squared. Does this, it almost looks like it's going to be factorable. I don't think it is though. Could this be the result of some identity? I wish sine had more double angle formulas. We could try to get everything as 2x. So we just have the same power. It's like sine x. Well, that's not simply done. No, that's not simple. What can we do? I mean, having things on different angles is just a non-starter for me, so I'm gonna keep that cosine squared x there. Because having x and 2x is just, I think it's gonna make things a lot more complicated. The thing is, the sine x and cosine x being married here is, it messes up a lot of things. We could say that cosine squared is 1 minus sine squared. I don't see where that gets us, though. Does it get us somewhere? Like, maybe we get something that's factorable now? Ones go away. Can we do anything with this? From minus pi to pi? Let's see what Wolfram Alpha has to say about this problem. What's the problem? Sine x plus sine 2x. Yeah, like it would be great to get it as a quadratic. That's just, it seems to be easier said than done here. I'm trying to look for something that's factorable, but I'm not really seeing it. So we are expecting two solutions here on our interval. Is that what you wanted to do with this, Jeff? Solve that for x? They're actually, I mean, I think Wolfram Alpha is giving it a complicated way. That might actually be like I'm sure it is a valid way to do it too. But I doubt it's the intent of the question. Oh, it's not a good sign when Wolfram Alpha gets it numerically. So Wolfram Alpha doesn't know how to solve this either. .14159, so that's just pi. I wonder what the 0.15 is. Like, maybe we could guess that that's like pi over 8 or something like that. Probably even pi over 16. You know, just out of curiosity, could we cheese to figure out what the answer is here? Wolfram Alpha is just approximating. We want like 0.15? Oh, that's 0.19. Well, 32 is going to be too much. It doesn't have to be power of 2, I guess. I'm just... almost there. Ah, then that's too far. Okay. Well, that's probably not the most efficient way to solve this problem. No, Jeff, it's true. There's two solutions here on our interval. I still couldn't tell you how you get them. Oh, yeah. It's not an identity. Like, Zam, you have 6 minutes per exercise? This is, how do you do this in 6 minutes? All right, could we try something completely off the wall? Like, can we say that sine 2x is the result of an addition, like an addition identity with x plus x? Where would that land us? I'm looking at my formula sheet right now. For me to try something off the wall? Thank you, Ben. Oh no, I think it's your same double angle identity. Never mind. I mean, you could do like 2x minus x. Or rather 3x minus x, but that seems, no. Well, this formula exists. Sum product to sum? The sine x cosine x was messing with me. This would split it up into sines. But we're gonna get more half angles, I think. Half angles of sine. Oh my god. It's like sine cubed, sine squared, cosine, sine, cosine squared, cosine cubed. Something that's potentially factorable, yeah. How would you get that? Talking about maybe multiplying through by cosine? Well, that doesn't really get you there, though. Hmm. But you seem to win. Need to move sine out? I do? I don't see what you're saying, Yuri, I guess. Like factoring sine out of the step that I have here? Well, it's the cosine on the end that messes everything up. Like this cosine over here gets left out of that factoring. I guess, oh, wait. I guess you would still factor the sine out. You just get a cotangent? Or, no, that's just tangent. Because tangent, no, it's cotangent. That's true. So that's a simplification. Anything with sine x equals 0, I guess, in theory works. Is that even true? Sine, it's, so 0, but 0 isn't a solution, so I did something wrong. Or are we just getting superfluous solutions? Because not everything is bidirectional. 0, you get 1 equals 2. So 0 definitely isn't a solution. But this might still be valid math if we look at the other part here. I think, oh yeah, because we just divided by sine, I guess, basically. That's what I did at first. That's the identity you asked about. It turns into cosine of 2x, though, and that 2x on the inside messes things up. For me, it's 30 minutes, a few pages of solutions. I mean, I don't know how long I spent on the problem, but I'm a little I'm at a loss so far. I mean, so we've gotten rid of a sign. I still don't really see what we do though. That is a nice like call out that we can like chop off that sign. Or it's a good like technique to have in my pocket. I just think in this exact case it might not help. Maybe in some other configuration it does help. Oh no, I appreciate the suggestion though, because it's good to have that in my mind. On the other side is 1 plus 2 cosine x sine x plus 1? Well, that's sine x. Ooh, all right, let's investigate that because I feel like I'm. Oops. Oh God. So it sounds like you're saying from this step we could potentially factor out a sine x just from these first two terms. And this looks sort of like a half angle with cosine, is what it sounds like you're saying. It's not, though, because we would need a squared, or that'd have to be like 2x or something like that, though. Well, you still could apply it, it just is going to look messy. Hmm. We could Google it, but I'm getting close to just saying that I don't know the answer here. Pretty insane test. You have to do that in 6 minutes. Never heard of this site. What? That's a trig identity? It wasn't the exact thing that we had. Well, actually, it was pretty close, though. Oh my god. Frickin' Opera. Is that what we have? It's nearly what we have. It's not quite, though. Well, I think I got something really close to this, though, at one point. This might just be a rearrangement of this identity with tangent. Oh no, it's an, this is an identity, though. It's not... We might need this identity, though. It's really close to what we have. We have a... Ah, shoot. Oh, we have a sine 2x. We have a 1, a cosine... All right, let's try this identity, I think. Where can we shoehorn this identity in? Something in the sum of solutions? I think, from what I remember from Bio's other questions, I think the questions are often asked like that just so you can't plug the possible solutions back into the original equations. It's to prevent that, like, cheating, or, you know, cheating way of doing multiple choice math questions. So this actually might be a 6-minute question if you just happen to know super vague identities like this. And if you don't know vague identities like this, then you're just screwed and should probably just skip it. But this might actually be the identity that we need. You can't look possible. Okay, yeah. So can we engineer this situation? We're nearly at this situation just with the equation as it is written. Let's subtract the 1 to the other side. -1 plus cosine x plus, now cosine squared x, we do have to do a half angle here, double angle, half angle. 1 plus cosine 2 theta over 2. 1/2 plus 1/2 cosine 2x. So what do we get here? We get -1/2 is the issue here. So that's preventing us from using this identity. And the half in front. Oh man, the half here is what kills us. We just can't use this identity. What the heck? All right, one more attempt and then I'm not sure, but let's turn the sine 2x back into sine x cosine x. Instead, let's really force there to be a cotangent. Well, this cosine squared, let's still use our half angle here. Well, oh, no. We want the angle to be the same here. Let's just divide both sides by sine. One over sine, that's cosecant. Cosine x. Now, do we want to use this identity here? That was my thinking with something like this as the purpose for dividing by sine. And if this doesn't work, then like I think I'm at a loss here. Well, we have to use it twice. No, this is stupid. I don't think this works. Well, it could. Okay, well, let's keep pursuing it. This looks horrible. Horrible. Hey, Lucky. Oops. I don't think this is it. You found a solution? Oh, I'd love to hear it. And Lucky, yeah, we'd have to. I tried using that identity. I still didn't it's so hard to get something that's factorable. I didn't see where to go after using that identity on the cosine squared there. Yeah, if I'm out of ideas, so if Yuri's idea doesn't work, then I have to tap out of this question, I think. Should be reduced to a homogeneous equation. We can do that. Do you just mean like subtracting everything over? Yeah, Lucky, we were trying that one too. It's I tried about every identity that I could think of, including some super vague cotangent identity that I was like, oh, maybe this will help us. One is sine 2, cosine 2. Oh, changing. Oh, I didn't even think about using the 1. There could be something to that. Because 1 is equal to sine squared plus cosine squared. I don't know if that is going to help, but let's investigate. So the cosines are going to go away. The cosine squareds, rather. So we had a cosine x. Who wrote this minus sign here? What does this mean? We have a sine. It's a sine x. Okay. We'll rewrite that. All right. I think we're at the same exact spot that we were at in one of the other attempts here. This is where we factored out the sine out of everything and got a cotangent. We have the plus cosine squared here and the minus cosine squared here, so they add to 0. And Lucky, if you still have that question, please feel free to post it. This is the, just solve this for x over the given interval. It's from bio. There in chat. That's all the information I have. From Wolfram Alpha, there should be 2 solutions. Like 1 plus 2 cosine x sine x. So you're saying to take the sine x out of here and here? I don't think 1 plus 2 cosine x is anything, though. Yeah, it probably is that idea. We just have to get there, which isn't easy. But if we have 2 solutions, it's going to be quadratic at some point. We just need to get it in that form somehow. Yeah, I don't think like 1 plus 2 cosine x, I don't think that's anything. One minus 1 cosine squared? Like do a plus cosine squared minus cosine squared kind of thing? I mean, to help us factor? I don't know though. I don't know that identity that you're using. Change minus 1 into cosine x minus sine x? I don't think that's an identity. It's the arc cotangent of a quartic? Okay. I think I'm stuck here. I don't think I know the answer here, Bio. So yeah, Blocky, if you saw that integral, please feel free to post it. Wait, Jeff, you got it? Cosine of arctan x. Yeah, you draw a right triangle. So cosine is adjacent. Yeah, it's 1 over root 1 plus x squared. You do a change of variables, x equals arctan u? You end up with stuff. Oh wait, no, it's not cosine of that, it's just this. Oh, I see. Okay. We'll try Jeff's way. So I miswrote it. It's just this. It's not cosine of that. So then I'll be really sick if that doesn't work, I guess. Hey, Brian. X equals arctan u. Shoot, I should have kept that triangle up. X, 1 plus x squared. So sine of that triangle is x over root 1, or I need to do u. U. Yeah, we end up with u's. I should put, it should be u's in this triangle. That's why I was getting mixed up. 3 pi over 2, is that actually one of the answers? Sine is -1, -1, 0, 0, 0. Oh my god, 3 pi over 2. All right, so the solution is to just look at it and guess 3 pi over 2. No, a second one exists that's negative. So is it just negative pi over 2? As the negative solution? We already got minus pi over 2? Oh, you're right. It's negative pi to pi. Minus 2 pi n. There should be two solutions between minus pi and pi. Oh yeah, that'll be for the sum, right? This room comes from this monstrosity. Wait, sine is opposite of our hypotenuse? Okay, yeah. What's up, Brian? Please do. I would love it if you could. Wait, what do you do with it? Oh, you have to use identities on the double angle. I would love any way to get out of having to actually solve this. So the possible solutions for the sum of the two solutions are pi over 3, pi over 2, 3 pi over 2, negative pi, and minus pi over 2. You might have also found valid solutions, Yeri. They're just not in the interval. Get everything on the left-hand side and get 1 minus cosine squared is sine squared? Yes. What do you do with the sine 2x? I don't know if I tried that exact thing, but I definitely tried something like that, and I got stuck. It might just be my fault, though. You know what? This actually is not that bad. I'm gonna say it. Then the cosine x makes it hard to factor, I guess. Brian, I've tried a similar thing, I think. So I've had a lot of attempts on this problem, but I keep deleting them. So my work isn't here, but I think I've done something like that, and at least I got stuck, but it may have been my fault. Or maybe it's still been a valid way to do it. So I would like to multiply through something and get rid of the denominators. Do I have to multiply by 1 plus u squared to the 3 over 2, though, to actually get rid of things in a meaningful way? Well, no. If we just multiply it by 1 plus u squared, we get u root 1 plus u squared plus 2u plus 1. And 1 plus u squared is never equal to 0, so we're okay. This is not that bad. Wait. Is this actually how you're supposed to do it? The 1 goes away. Well, how do you solve this, actually? I guess you can do... And now we isolate the square root and we square. Okay. U not equal to 1 here, though. -1. We need to remember that. Hey, Pikachu. Okay, it's... Oh, wait, this is gonna be a Quartic, dude? Oh, no. That's right. You did warn me. Yeah, the sign of arctan stuff can come up a lot. All right, so what do we get? Let's do the u squared first. U to the 4th minus 2u cubed plus u squared plus u squared minus 2u plus 1 equals 4u squared. U to the 4th minus 2u cubed. If this actually gets us the solution, then Jeff is a hero. You know, and you're gonna fail Stump the Streamer class because you'd be helping me understand how to do a problem. That looks like you could. Oh, dude, there's a factoring trick here, isn't there? We have two separate things. Wait. Oh, the signs. Why don't the signs work? The signs should work, right? Well, okay, that should be a minus there, but the signs still don't work. Can afford 1 point off? Distract the streamer? Yeah. Distract the streamer from moving on to a problem that he can actually do. Oh, you can't group it? Come on. I just did something wrong and this still groups, right? Maybe it just doesn't group. Let's plug it into Wolfram and see if this actually worked. So what's our Quartic? Let's do x is x to the 4th minus 2u cubed. This is, I feel like this isn't the intended solution because it takes a million years and bio has 6 minutes. So I feel like there's still some other way to do it, but this is definitely a way. Minus 2u plus 1. Two solutions. All right, well, it definitely doesn't factor cleanly. So let's just take that. And x equals arctan of this. Just write out this entire irrational number and that's your solution, I guess. I don't know. I think I made a mistake at some step because it should have been unit circle. So I think I made an algebra mistake somewhere. And I don't really want to go back and fix it. Let's end the... Oh, Lucky, is this your integral question that you posted? So yeah, I think I have to take the L on this one because I'm not sure. Let's look at Lucky's question. And I know you asked about binomial theorem. We will get to that bio, but since I've already done a few from you, I want to get to Lucky's. And I'll switch back to binomial. And to be honest, for, like, I don't know the binomial theorem that well myself, so it would just be me Googling something and trying to verbally explain it. Which I'll absolutely try to do, but I'm just, like, warning you now that... Oh my god. Oh my god! It's probably the best that I'm going to be able to do for binomial. What's happening here? Not a question really, just understanding why the limits change in this way. So we're switching the order of integration here. Why would that change your limits? That's a good question. Because we're going from 0 to x. I'm not sure if this is why. Let's just think about it like from t equals 0 to t equals x. T f of t dt. And so now if you want to switch these, t is going from 0 up to x, and x is going from 0 to a. I think there's going to be some kind of geometric explanation here. I think you did find some solutions, but not all solutions with that form. Because minus pi over 2, I think definitely works. And I don't think that form captures minus pi over 2. Unless I'm misunderstanding how you typed that. Yeah, so there's definitely... I'm just saying that there's more solutions than have been captured with 2 pi n. There's definitely 2 solutions in the interval from the graph. I just don't know how you get them. It might, honestly, the answer to that one might just be eyeballing it and trying clean numbers. Like, if you have to do it in 6 minutes, like, guess and check might unironically be your best bet. So t is going from 0 to x. I don't know if this is the best way to interpret this, but... And x is going from 0 to a. So I guess the region that we're integrating over is this red triangle here. That's definitely a thought, Lockie. Just having things at different angles makes it so much harder, though. I'm not sure how you go from there. And so if we want to capture this same area... Oh! Okay, I think this picture does help me out a lot. So all that I've done with this graph here, Lockie, is take our limits here and try and graph them just on a, I guess, tx plane. So the kind of function that we have in our limits is t equals x, which is just like y equals x. So I just draw, like, you know, a normal y equals x line. And if t is going from 0 up to... Oh, wait, no, maybe I didn't draw it right. It might be the lower triangle. No, yeah, t is going from 0 up to x, so it should be the lower triangle. Oops, maybe I didn't figure this out. T is going from 0 to x, wherever x may be, and then x is going up to a. So does this triangle still... This point right here is also A. So, okay, no, I think this is what we want here. Okay, so the reason that, okay, so we are integrating over this lower right red triangle here. And since we're doing our x's first, our x goes from this line, t equals x, out to a. That's why we go from t to a. Because we have to get that lower right triangle and starting from the x-axis here now. So we have to start at the line and then go to the right. And then t is still going 0, or then t is just going 0 to a, I think. That's my guess. I'm not that good with this type of, when we don't have like hard numbers to plug in. But I think that's the situation that we're working with here. I don't know why I'm making the rest of the integral, but it makes sense? Okay, good. So yeah, I guess the only thing I can recommend to you in general with a question like this is to actually draw out the region you're integrating over as I did here. And then start from scratch to rebuild it when you switch the order of integration. Not from, from scratch necessarily, but forget about the ones that you had before. The inner integral in the first part is the expected value with the f of t as a density mass. Oh, it's like a weighted average, I guess? Or not weighted, well, it's I think I recognize that form, I guess, as what you're saying, the density mass. From auction theory, I'd never heard of auction theory. Is it literally an auction, like people bid money to buy things? Oh, that's it. That is an interesting question, Yuri. I'll look in a second. Game theory slash... Oh, okay. That's interesting. Well, I think we're done with this. It sounds like we're on the same page with Lockie here. It's like a trap. I think I know the technique. Oh, yeah, sure. Please do, Lockie. I don't think this one will take me long, because I think I just know the answer. There's two situations where this equation is true. Either your base is equal to 1, or your exponent is equal to 0, and the base isn't also 0. Oh, you got it? Okay. Well, I'm glad to have helped. Please let me know if you have anything else. It's ambiguous? Why is this ambiguous? Is there a trick here that I'm not seeing? I thought the trick would be like it's not equal to 0 part. Like you have to check your solutions. Just solve it? All right. So we have to check these, but these are two potential solutions here. Okay. And then we have to verify. So is there a situation where 2 and 5 can't work? If does 1 to the anything ever not equal 1? 1 to the 0 is still 1. 1 to the 1 is still 1. Root 1 is still 1. Yeah, so I think these are all fine. Now, x equals 6 and x equals 7, do those give us a 0 over here? I don't think so, because it's going to have irrational roots. It could give us a negative number. Would that screw it up? It might screw it up for... It might have to be greater than 0, essentially. What about 3? Oh, is there a third thing that I'm missing where it could also be 3? 9 minus 21 plus 11. Negative 1? To the power of 9 minus 39 is negative 30 plus 42 is positive 12. That gives you 1. Oh, wow. What did I miss? There's another situation where this exponent can become 1? Negative 1 and even. Oh, I was literally just thinking about that when I was thinking about these. But I didn't make that connection. Okay. So yeah, you have to set equal to negative 1 as well. That is a nice trick. It's nice how these all like factor cleanly as well. I assume x equals 4 would give a an odd power, so it wouldn't work. Oh man. Only 4 solutions? Well, okay, so these 2 always work. 3 works. And then only 1 out of these other 4, 6, and 7 ones work. So, no issue with techniques? All right, I guess we have to just check these the old-fashioned way. X equals 6, you get 36 minus 42 is negative 7, plus 11 is 4. And we already found the exponent is 0. So x equals 6, I guess, works. Graph it on Desmos? All right, yeah. That'll be easier. You know, I did kind of forget about bioestimate, the binomial theorem. After this, I'll get back to that. I don't know if I'll be able to give you the best explanation of it anyway, though. Why are there only 2? Wait, oh. Why does it stop dropping me down, Desmos? Stop it. Stop. Why do you do this to me? There we go. Oh, brackets would have done the trick. Yeah, you're right. Wait. Did I type it in wrong? Oh, I did, yeah, I typed it in wrong. That's why. Thank you for the copy paste. Okay. So yeah, 2. It's a funky looking graph. 2, 5, 6, and 7. Wait, 2? 3 was an answer though. Is this... Oh, it's undefined. So wait, is 3 a trap answer? Or where... Why is 3... What's wrong with 3? You get -1 to an even power. Oh, because it's just a single point? It's not defined for like 2.5, I guess? Definition of real number lacks definition for powers of negative numbers? Really? I didn't know that. Whoever made the real numbers was kind of slacking, I guess. Huh. Yeah, Lucky, thanks very much for the question. Glad I was able to solve it. That's a cool one. It works for integers. I mean, is -1 not an integer? Oh, because -1 has to be an integer, but if you're thinking about it in terms of real numbers, I don't know. That's a part of math that I'm not that familiar with. Bio, are you still here? Do you still want to talk about like the binomial theorem? Oh, really? So another math streamer, E2Y is doing this real analysis class on Twitch, and in that class, we define the real numbers as the completion of the rational numbers, I think was the term. Which I'm not very good at interpreting it, but... Oh, fractional powers. Oh, okay, yeah, that's where it does get messed up, for sure. Okay, yeah, I remember that there's some really weird facts with That's true. I remember someone teaching me that some really unintuitive thing with powers of negative numbers. Okay, I haven't. Bio might have had to leave, so sorry if So I guess for now I'm not going to look at the binomial theorem. Let's see if anyone replied to us. Looks like someone did. Oh, good. Okay. Not for tooting your own horn in the process like so many others here do. What's this argument happening here? Doesn't, oh, I mean, okay, I mean, I don't get the point of arguing here in the first place, but it's not important. Let's just move on. The person got their help. That's all I care about. That person just said thanks. A sum of Heaviside step functions. Oh, you could do that. Oh, that's the answer for how you would integrate a step function, I guess. I forgot about Heaviside. But it's still going to end up being the area of 3 rectangles. Okay. It's just a fancy way to split it up. Well, this person's just posting their geometry homework, it seems. Actually, it's a, did they triple post? That all the thumbnails look the same. I'm going to move on. Look at Learn Math. $50 over 1.7 with mental math? Not by, okay, you know. Be a computer, I guess. I don't know how you solve that. It has complex solutions? Do you sub in e to the, or like re to the I theta for x? Try and work it from there. I don't know enough about it to attempt that though. This is a nonlinear ODE. Separable. Oh god, this is one of those ones where you have to solve it in a particular way or else like get an answer in the wrong format, and it's really hard to see the format that the book wants it in, it feels like. I don't like these questions. I do like differential equations, but actually, is this separable? It should be, because it's just the t to the fourth. So when I actually do the algebra in my head, how do you get the t to go with the dt? You know, I'm not sure. I'm kind of feeling tired. I've been streaming a lot this week, and well, I mean, I technically took an unwilling day off because my power was out, but I'm still feeling tired. So I think I'm gonna call a stream here. I have done my 2 hours of math, which is my usual like kind of goal for the minimum. And I'm just gonna take it a little easy because I'm feeling like if I don't take a break, I'm gonna get a little like burnt out. So I'm gonna cut the YouTube stream off here. If you are on YouTube, I thank you for being here. Oh God, what's happening? Okay, sorry. Thank you for being here. I'll be back with Math Stream on Tuesday. So yeah, see ya, YouTube.